Section 3.2 Impulse changes momentum. So in physics and in science in general, we use the Greek letter delta to imply the change in something. So from an initial condition to a final condition, the change in velocity we will write as delta v, the final velocity minus the initial velocity. Similarly, we can define impulse as the change in momentum. And so the final momentum minus the initial momentum. In physics, we use a lowercase p to represent momentum because we use an m for mass. Now in this section, we're going to talk about how impulse can change momentum. In the last section, you saw how a force over some amount of time implies an impulse, and that impulse changes momentum. So we're going to talk about how those things occur in different ways. The first way is if you increase the momentum of something. So something's already moving and you want to get it moving faster, or something's not moving and you want to start it to moving. Right? So what you want to do to increase the momentum is to increase the impulse. You want to increase the force that you apply, and you want to apply it for the longest amount of time possible. Right? So this is why baseball players and golfers, they follow through on their swings. This is meaning that the club or the bat is in contact with the ball for a longer amount of time with, a similar amount of force. The longer you're in contact with the ball, the greater the change in the ball's momentum, the further it's going to go. Now, in these situations, obviously the force isn't always uniform, so when we talk about the impulse, we talk about the force as an average force over the entire swing or over the entire action. Right? In a few minutes, we'll talk about collisions, the average force over the entire collision. So the second situation is when you decrease the momentum of an object over a long period of time. So say you're in a truck or a big heavy vehicle that's out of control. Do you want to crash into the concrete wall, or do you want to crash into the haystack or the bales of hay, right, or the cornfield? Right? You're going to go for the cornfield. The reason is that the corn stalks and things will slow your car down, but it'll do it over a longer period of time. Whereas the concrete wall will slow you down, but it's slow you down quick. By stretching out the force needed to stop you over a long period of time, you reduce the amount of force that you experience. You reduce the amount of force that's required at any one particular time. So throughout that trip, you're slowly slowing down and you don't really get injured. Whereas if you hit a wall, you slow down really fast. And if you slow down really fast, then you experience a large amount of force. You still have to come to a stop either way. The change in your momentum is still going to be the same. You're going from a velocity of something to a velocity of 0. So you still have the same change in momentum. But your force that you experience, if you can stretch it out over a longer period of time, means that the force you experience is much less. Now, this is why when you jump up and you land on the ground, you don't land stiff-legged, right? You bend your knees when you land on the ground. By bending your knees, you extend the amount of time that your body has to withstand the force of you landing on the ground. And so therefore, you lower the force. The third case is when you decrease momentum over a short period of time, like we talked about with the car hitting the wall, right? In that case, the forces have to be much larger. So if you can change the momentum or decrease the momentum of an object over a long period of time, right, you can apply a really small amount of, a really large force over a short amount of time. Then you can do things like break bricks or break boards or things with karate chops. Okay, this is a large change in momentum over a very small amount of time, which means very great force. Similarly, some objects, when you drop them on the ground, they bounce. And because momentum depends on a direction, bouncing implies a change in momentum. The object goes from traveling in one velocity, or traveling at one velocity in one direction, to traveling at a different velocity in the opposite direction. So the velocity changes, the direction changes, so the momentum changes. Now most objects, like elastic objects, they tend to stretch and things when they bounce. And that's why they're able to bounce so much further. Right? They can experience that force over a long period of time, and you have a much larger elastic force. The momentum changing as something is bouncing, as something is turning around a direction. You can think about it kind of like a baseball player. If a baseball player is trying to hit a home run, not only does that baseball player have to hit the ball to stop it, the baseball player has to hit the ball to stop it, and then hit it hard enough for it to go in the opposite direction, 400 feet or whatever it is. The catcher only has to catch the ball and stop it, so it requires much less force.